Alright, so right now we're going to talk about predicting products. You don't need to write this, it is just a reminder. You must know the polyatomic ions and 5 types of reactions to properly predict products. So, step 1 in predicting products, you've got to keep in mind that water is really made up of H plus and OH minus ions. So water is really made up of H plus and OH minus. So when you see water in a reaction, what you really want to do is rewrite it or think of it as H plus and OH minus bonded together. Okay, now when I look at this, I have a positive ion and a negative ion, and a positive ion and a negative ion, 2 plus and Cl minus. That makes me think it is prime for a double displacement reaction, because our positive ions are just going to trade places. So this H is going to kick the Cl out, kick the Mg out, positives kick positives out, and it's going to bond to the Cl, and we're going to have HCl, and then what's left over is the Mg that got kicked out and the OH that got left behind, so MgOH. Now, this HCl looks pretty good to me, because H is plus 1 and Cl is minus 1, but magnesium is 2 plus, but our OH is just OH minus. So what we need to do is have 2 OHs, so MgOH2. You guys are really good at balancing at this point in time, so I'm not going to take time to balance these so that the notes are a little shorter, but just know that after you do all of this, you'll need to balance the equation by putting coefficients in front of some of these. Sorry. Pause the video if you need more time, otherwise I'm going to move on. Alright, so number 2. Positive ions, which are called cations, trade places with other positive ions, and anions, which are negative ions, trade places with anions. So if I have magnesium plus cesium chloride, I know that my magnesium is 2 plus. I know that from the periodic table. I know that my cesium is positive and my chlorine is negative. So I know that this is going to be a single displacement reaction because I have only a positive Mg here, but it's going to kick out that positive Cs to form MgCl and Cs by itself. But this MgCl isn't quite right. I imagine you guys know why at this point in time, because Mg is 2 plus and Cl is minus. So we actually need 2 Cl's there. Alright. This is an example of a double displacement again. Sodium's plus 1, sulfate's minus 2, barium's 2 plus, nitrate's minus 1. That's why we needed 2 nitrates there. So, our positive sodium is going to kick out our positive barium, and Na is going to bond with NO3. So I'll have NaNO3. Now the barium that was kicked out bonds with the sulfate that's left behind, and you get barium sulfate. This one is actually nice the way it is, because sodium has a plus 1 charge, and nitrate has a minus 1 charge, barium has a 2 plus charge, and sulfate has a 2 minus charge. So, those guys are set. Alright, 2 more example problems and we're done. Sorry, I'll just balance these really quickly. 3. You create water whenever possible from as many H's and as many OH's are there. So in this case we have H2SO4 and NaOH. Go ahead and pause the video for a second and make sure everyone's caught up. Continue it in about a minute. So what's going to happen here is your hydrogens and your hydroxides are going to bond together to form a water. And there's our water. If you take out the hydrogens and the hydroxides, what you're left with is Na and SO4. Because Na is a plus 1 and sulfate is a minus 2, you need 2 sodiums to balance it out. because here we just have a negative. Here we have a positive, and here we have a 2 negative. So we needed 2 sodiums to balance it out. Alright, one more example problem and you guys will be able to finish the last 6 or 7 problems from that worksheet. If it's a transition metal like copper 2 or lead 4 or what have you, then if it's that charge on the reactant side, you'll keep it the same charge on the product side. So for example, here we have tin nitrate. Nitrate's got a -1 charge. If we have 3 of them, it must be tin 3 nitrate. This looks like it's going to be a double displacement reaction. The tin's going to kick off the cobalt and form with sulfate. So on this side, we'll have tin sulfate. The reason the numbers look that way is because it's still tin 3. Because it's tin 3 and sulfate's got a 2- charge, we needed to do 2 times that +3 to get 6 positive overall. And we had -2 for this sulfate times 3 is 6-, and they cancel each other out. Alright, the same is true for the cobalt. This is cobalt 2 on this side. You know it's cobalt 2 because your polyatomic ions you have plenty well memorized at this point in time, and sulfate's a -2 ion. So cobalt must be a 2+ element. And so you have plus cobalt 2 sulfate on this side. Because the cobalt was bonded to the sulfate on this side, it's going to bond to the nitrate on the other side. And so you'll have plus cobalt 2, because it'll stay cobalt 2 nitrate. Because the cobalt was 2+ and nitrate is only -1, we needed 2 nitrates, so 2 times a -1 would be 2 negative, and they would cancel each other out. Alright, you are now ready and able to do the last 7 problems, 13 through 19, on your homework. Again, help each other. Make sure no one leaves with questions. If you have a question, ask it now. Oftentimes students are better helping than teachers are because they know exactly what they first messed up on, so they'll be able to help you with what you might be messing up on. So, ask questions of each other, help each other out. Good luck.